This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on sum and difference identities for trigonometry. So here's the identities we're looking at: cosine of alpha plus beta, sine of alpha plus beta, tangent of alpha plus beta, as well as cos alpha minus beta, sine alpha minus beta, tangent alpha minus beta. The ones you should memorize, frankly, are probably these first two. And then all you've got to do is replace beta with negative beta, and you can develop those two. Tangent, not quite as important, but we'll provide those for you. So here's our first example. We've got the cosine of 75 degrees, so we've got to decide which one of these are we going to use. Now, the angles that we know fairly well are 30, 45, and 60. So keeping that in mind, we can rewrite cosine of 75 degrees as cosine of 45 degrees plus 30 degrees, which moves us into this first identity. So we're going to let alpha be 45 and let beta be 30. And then plugging in those values, we'll get cos 45, cos 30 minus sine 45, sine 30. Now what are those values? Cosine of 45, root 2 over 2, or 1 over root 2. Cos of 30, root 3 over 2. Sine of 45, root 2 over 2. Sine of 30, a half. So then we have those values, and then how do we simplify this? Root 2 times root 3 is root 6 over 4 minus root 2 over 4, multiplying that. And if you'd want to, you can get a common denominator. Common denominator is 4. So my result is root 6 minus root 2 over 4 is my answer for the cosine of 75 degrees. Okay, let's look at another one. Here I've got the cosine of 105 degrees. So again, we know 30 degrees, 45 degrees, and 60 degrees. The one we'll get here would be 60 plus 45. So which formula are we going to use? It'll be the second one. We're going to let alpha be 60 degrees and beta be 45. So it'll be sine 60 cos 45 plus cos 60 sine 45. Sine of 60, root 3 over 2. Cos of 45, root 2 over 2. Cos of 60, a half. Sine of 45, root 2 over 2. And then we get this. Multiplying those together, root 3 times root 2, again, root 6 over 2 times 2 is 4. This is root 6 over 4. 1 times root 2 over 4. And you'll see our answer there is root 6 plus root 2 over 4. Very similar sort of approach for these two problems. Let's take a look at the tangent of 15 degrees. Well, 15 degrees will be 45 degrees minus 30 degrees, which will move us into this formula. So rewriting that as the difference, 45 minus 30, alpha will be 45 and beta will be 30. Substituting that, that'll be tangent of 45 minus tangent of 30 over 1 plus tangent of 45, tangent of 30. So again, alpha is 45, beta is 30. And here is our substitution. Tangent to 45 degrees is 1. Easy to remember that one because sine and cosine are the same. They're both root 2 over 2. Tangent of 30 degrees, a little harder. Tangent of 30 degrees is sine of 30 divided by cosine of 30. Sine of 30 is a half. Cosine of 30 is root 3 over 2. So the tangent would be 1 over root 3. So what we get now is we get 1 minus 1 over root 3 in the numerator and 1 plus 1 over root 3 in the denominator. Now the simplest way to simplify this is multiply this top by root 3, multiply the bottom by root 3. What do I mean by that? So you can see the top fraction multiplied by root 3, bottom fraction multiplied by root 3. This doesn't change the value because root 3 over root 3 is just equal to 1. So we're building an equivalent fraction. Next, distribute. Root 3 times 1 is root 3. Root 3 times 1 over root 3 is just 1. So the top becomes root 3 minus 1. On the bottom, root 3 times 1 is root 3. Root 3 times 1 over root 3 is just 1, so we're going to get root 3 plus 1 on the bottom. And our answer will be root 3 minus 1 over root 3 plus 1. Our next example is to do a proof. We want to prove that the sine of x plus pi over 4 plus the sine of x minus pi over 4 is the square root of 2 times the sine of x. So we'll need to use the sine of alpha plus beta formula here and the sine of alpha minus beta formula there to make that work. So in our first case, we're going to look at sine of x plus pi over 4. So alpha will be x, beta will be pi over 4. Sine x cos pi over 4 plus cos x sine pi over 4. Now, cos pi over 4 is root 2 over 2. Sine pi over 4 is root 2 over 2. So replacing those guys, we get sine x root 2 over 2 plus cos x times root 2 over 2 will be our sine of x plus pi over 4. The next thing we want to do is going to do the sine of x minus pi over 4. So using this formula, alpha will be x, beta will be pi over 4. Sine x cos pi over 4 minus cos x sine pi over 4. Cos pi over 4, root 2 over 2. Sine pi over 4, root 2 over 2. So we're going to get sine x root 2 over 2 minus cos x root 2 over 2. The next move is to add these things together. So if I take the sine of x plus pi over 4 plus the sine of x minus pi over 4, this plus this is all of this plus all of this. You'll notice cos x root 2 over 2 minus cos x root 2 over 2 is going to cancel. So then what do I get? Sine x root 2 over 2 plus another sine x root 2 over 2, which is 2 times sine x root 2 over 2. This 2 and this 2 divides out, so that my answer is going to be sine x times square root of 2, or square root of 2 times sine x, thus proving this. Now, these formulas, these product to sum, these sum and difference identities are important, but frankly what's more important are the double angle identities. So how can we derive the double angle identities from these identities? Well, if I look at sine of 2 theta, what does 2 theta mean? 2 theta is theta plus theta. So if I'm looking at sine of alpha plus beta, replace alpha with theta, replace beta with theta. What is that going to give me? Sine of theta cos theta plus cos of theta sine theta. Recognize these are really the same thing. Sine theta cos theta plus another sine theta cos theta. So we get our double angle identity here of 2 sine theta cos theta. Now how about cos theta plus theta? Which rule are we going to use there? So cos theta plus theta would be here. Replace this alpha with theta, replace that beta with theta. So we're going to get cos 2 theta is cos theta plus theta, which will give me cos theta minus sine theta. And what is that going to give me? Let me go ahead and make a slight change here. So cos theta minus sine theta is just cos squared theta minus sine squared theta. And that's our double angle for cosine. And the last one we'll look at is tangent of 2 theta. So tangent of 2 theta is tangent of theta plus theta. What are we going to do here? We're going to replace that alpha with theta and that beta with theta. That will give us tangent of theta plus tangent of theta upstairs. 1 minus tangent of theta times tangent of theta downstairs. So tan theta plus tan theta upstairs is 2 tan theta. Tan theta times tan theta downstairs is tan squared theta. So upstairs 2 tan theta, downstairs 1 minus tan squared theta. And that will conclude this lesson.